what we're going to talk about in the next hour is how do you automate security and compliance for a hybrid environment from an infrastructure point of view, but also from, so the ops point of view, but also from an OpenShift point of view. So kind of tie what you've heard throughout the day, kind of tie it together with a nice security bow. You know, what is the security stance for this particular use case? And I'm telling this story in a different way in the sense that I spent the first 3 years of my career at Red Hat as a cloud solutions architect for US public sector. So I was a product specialist, so I focused on our cloud products, OpenShift, OpenStack, Ansible, CloudForms, et cetera, across all of US government, from DoD to US intelligence agencies to multiple various civilian agencies. So I got to hear their very unique security use cases as they were trying to use our cloud products. So what you're about to see in terms of what I show in terms of demos and everything is an accumulation of some of these demos and proof of concepts I created for these customers, the lab environment that you're about to see was created by me and my teammates for Red Hat Summit. And so it's either a use case that I particularly had or maybe one of my teammates had. So this is kind of how how I'm gonna approach this. I'm gonna show you in what I call Red Hat buffet format, in the sense that you're going to see a lot of various Red Hat technologies and how they're integrated together and everything. Doesn't mean that you're going to use all of this. Maybe you're not the different stages, and that this is not really parts of it's not applicable. But the idea is you see, like I said, a Red Hat buffet, and then you pick and choose what's relevant to you. So this is a much more practical format in terms of, I'm hoping that at least one or two things I say is something that you can use tomorrow, that you can use today, that kind of thing. So let me first quickly introduce myself. As Luke said, I've been at Red Hat a little over 4 years. Today, what I do is I work in the security, the global portfolio, Red Hat portfolio team in the business unit. And so what that, focusing on security, and what that means is I focus on things like, what is our go-to-market strategy for security across all of Red Hat's products. What about creation of technical content as it relates to security across all of Red Hat's products, evangelizing that content internally and also externally, working very closely with product management and engineering to drive our security roadmap across our portfolio, things like that. As I said, I spent 3 years, most of my time at Red Hat as a cloud solutions architect for US public sector. That's actually what you get when you join Red Hat. You get a Fedora and you get a laptop. I have a Linux RHEL laptop right there. That's my laptop, the same one I have here. As you can see, that's my first sticker, and over 4 years, my sticker collection grew. So that's 4 years at Red Hat. My very first job, however, was at my parents' restaurant. My father specializes in what you call Korean Chinese cuisine. For those of you who are Chinese out there, it's jjajangmyeon, but Koreanized, right? And so one of the very interesting things about Chinese food that I realized is like it's different everywhere you go. India has their own version of Chinese cuisine. Korea has their own version. Don't go there saying, oh, I got my General Tso's fix. Can I get some General Tso's? If you go say that in Korea, they'll be like, I have no idea what you're talking about. There is no General Tso's chicken. There is no chicken and broccoli. There is Korean Chinese cuisine. That was my dad's specialty. This is the skill that he brought to the United States and brought his entire family without knowing a single word of English. And there's a phrase for this. The American dream in Korean it's 미국 바람, which means Korean wind. So 미국 is American wind. So he got this, in the early 80s. I was like 3 or 4 then, and then he brought my entire family there. And he opened up this restaurant, one of the first Korean Chinese restaurants in the Washington, D.C. area. And that 20, 30 seat restaurant, my sister and I helped out a lot. It was family-run business, right? And that's 20, 30 seat restaurant, maybe it was like 20, maybe 40 seats. Sent both my sister and I to Carnegie Mellon University. I ended up studying, I went the traditional engineering route. I studied electrical and computer engineering there. And I was convinced at the end of it that I wanted to be a processor designer. I studied superscalar processor design. All the speculative execution stuff, I spent like multiple processor classes doing stuff like that. So it's very ironic to me, this meltdown in Spectre. I was like, are you kidding me? All of these hours I spent, were thinking about speculative execution and superscalar processors. This is what, it was targeted for this vulnerability. It's very ironic to me. The other thing is that right after I graduated, this was my job actually at IBM. My very first full-time job was at IBM Poughkeepsie, which is the home of IBM Z and IBM Power Series. This is where the mainframe was born. This is where the mainframe was developed. And I was there to be a custom microprocessor design for IBM Power 6 and Z6. And so I did that. I worked on multiple. I did that for like the first 5 years. So as you saw, my career I have had lots of different kinds of roles since then. But the idea is I created. I worked on the core processor team. So I did things like worked on the instruction fetch, fixed point, floating point, and on the processor architecture. So outside of Red Hat, one of my passions, a fun fact of me, is I have a certified therapy dog. So what this means is I take her to, she's been a certified therapy dog for over about 9 years now. And so what this means is I go to nursing homes, libraries. This is actually at the Washington, D.C. Public Library. And what she's doing is kids come in their pajamas on Wednesdays, once a month, and they read to the dogs, which I was like, oh, that's kind of cool. What I've realized over time being there is a lot of these kids are autistic. And what the parents told me was that my kid doesn't say a single word all day long. But one day, I didn't know that because to me, they're like reading to my dog, they're laughing, whatever. And then the parents are like, that is the first word he said all day long. So it's one of the most rewarding things I do with my dog. The other fun thing is Washington Dulles Airport invites our therapy dog organization during very high traffic times to de-stress the passengers. So basically, when the flights are delayed, we bring our dog and they're pissed at United. We bring our dog and we say, hey, would you like to pet our dog? And for that time, they honestly forget. They're like, oh yeah, sure. And then you talk about your dog and they're all like, oh, so cute, all this stuff, right? And then they forget. They're like, I'm sorry, your flight, and the intercom, they're like, your flight has been delayed 7 more hours or something, right? They're just like, can we just stay here? We'll just stay here, delay it again, right? So it's a lot of fun. So this is what I do, one of the things I do outside of Red Hat. So, okay, let's get started. So what are some common security challenges? I'm sure, who's ops and who's in the infrastructure side? And what about the development side? And what about the security side? So I'm sure many of you have heard this, right? Okay, look, everyone's doing patching differently. Everyone's doing configuration. I have no clue how the configuration changed, 5 months ago. There's a lot of finger pointing. Hey, Bob, did you change this config? No. Did you change it? I didn't change it. Oh yeah, the guy who just left the company changed it. You have no clue, right, what happened, right? This is a very common problem. DevOps and security are constantly pointing fingers, right? Though it's the ops problem, it's a stupid developer's problem or whatever, right? Whereas then the security team's like constantly on your back, right? Operations team's back to give them things that they need. Okay, prove to me that this passed. Show me the green light, red light. What's passing, what's failing, run this scan, all this stuff, right? So these are some common security challenges. Now let's look at a little bit more deeper. Now this problem gets escalated when you start introducing more, different environments into your infrastructure. So if you I'm going to start looking at Azure now. I'm going to start looking at Amazon. I'm going to start looking at containers. This idea, now your problem has exacerbated in terms of now you have more things to track. And there's, I have no idea what apps are running in public cloud. I have no idea who's accessing the public cloud, those kinds of things. You don't know, your complexity keeps increasing. You're introducing risk. You're manually monitoring system, for compliance, which was maybe okay when you had VMs and physical machines, but when you start having containers and when you start having things like Amazon or Azure and things like that, this is going to get very, very complex very fast if you start to do those kinds of things manually. You start to lose visibility and control. And the problem with this is if you can't see it, how are you going to control it? And how are you going to secure it? That's a huge problem. And the other thing is, you want a way to, you start to realize that you can't manage security policies consistently across the same way. The security policies you may have had in place for VMs and physical machines don't apply anymore when you introduce a SDN environment, or it doesn't apply anymore when you start to have containers where you're not patching the container itself. You have an immutable infrastructure. And then you want to give, your users are saying, hey, I want a self-service way of provisioning my environment, and whereas you don't want to, as operations, want to give the keys to the kingdom. You want to lock down that infrastructure, and you want to, not only that, abstract away the infrastructure from the user. So why would you want to automate security and compliance? So I want to bring up this quote. This is from the 2017 Verizon Data Breach Report, and this says that 81% of hacking-related breaches leveraged stolen or weak passwords. I just bring this up because that's a pretty high percentage for a problem that is one of the first things in any security profile that you look at. NIST 800-53, Center for Internet Security. Any of the US Department of Defense STIG, any of these you look at, this is like one of the first things they do. So the question is, why is in 2017 this many hacking-related incidents happening? This is one of the easiest things to prevent yourselves from being in trouble for, right? The other thing I want to bring up is that in this Gartner report, November 2017, they say that 99% of vulnerabilities exploited by 2020 continue to be problems that are already known by security professionals. So then again, the question is, well, if you already know about it, why aren't you doing anything about it? And again, why aren't you using something like automation? Why aren't you having an automation strategy in place to actually make sure that you don't run into this problem. You're protected from these security incidents. So the problem with manually ensuring security and compliance is that, first of all, of course, it's time consuming, tedious, and boring. You're wasting everyone's time. You're wasting your time. Number two, there's a phrase like, when a human enters a data center, you will encounter an error. It's not a matter of if, it's a matter of when. You will encounter an error or security breach. When you have bad actions by either internally in your team or, like I said, people leave the company all the time. How are you going to know what changes that person made? And how are you going to audit it and track it? So this becomes a problem as well. You can't easily do audits. You have this constant back and forth with the operations and security team. You can't share anything. Nothing's repeatable. Nothing is verifiable, or it's very hard to verify. Okay, so here is like the security nirvana, right? This is like the what should you have? And this is not an exhaustive list, but this list is what I've seen our customers do, at least in the US public sector. And the whole idea is you gotta take things baby steps. You can't try to achieve this well-oiled machine, security machine in your environment. You gotta take things little at a time, right? So what does those little at a time things look like? And specifically, this list is gonna show how we can actually help with this list. Number one, centralized management and visibility into the entire infrastructure. What I mean by that is, I don't care if it's Windows, Linux, virtual machines, public, private cloud, containers, everything has to be visible. Otherwise, like I said, if you can't see it, you can't even begin to try to control it or secure it. Everything has to be code. Infrastructure has to be code, and security has to be code. Why? Because that's gonna give you that repeatability, ability to share, ability to verify, giving you that easier way to pass audits. This is a constant goal of making the security team happy, right? You gotta pass those audits, right? You want to make it easy to pass those audits. What are some ways you can do that? Why not allow your security teams to see what they need to see without bothering the ops team? This was actually a use case for a government customer in the Department of Defense. They said, I am so sick and tired of the security team bothering me. This was a proof of concept. They said, give me a way of enabling this security team so that I don't have to give them root access or SSH access into the machine, but I want them to do two things. I want them to be able to have a report of what they want to see. Don't bother me. You be able to create it in a restricted access type of way. Number two, the other use case was, okay, not only create the report, but I want you to let them be able to, without SSH to the machine, be able to see very specific details about config files. That was the use case. Well, that's a huge benefit, right? Because now you've empowered the security team to get information they need without this back and forth between security and operations. So you have that less back and forth. Proactive scanning and compliance to security baselines. You want to be sure that you're in compliance to whether it's a custom baseline you have or a standard baseline such as PCI DSS, security controls, etc. You want to have a hardened image from the start. So you want to have this locked down hardened image. Why? At provisioning time, because that's going to give you that consistency. You're going to eliminate those snowflakes. You're going to have that immutable OS. It can't be changed by untrusted parties. You also want to have continuous security and continuous monitoring in an automated fashion. You want to build security into your application pipeline and automate as much as possible. So one of the big summaries here is that you have to have some sort of automation strategy in place. The strategy I present is, of course, Red Hat bias. It's Ansible, but it's in addition to our management portfolio. But it doesn't have to be that. But you have to have some sort of automation strategy in place, because that's going to give you that. Not only saving time and money, but reducing those risks, reducing those human errors, making sure you're protected from security breaches, especially those stupid ones like, password is weak or things like that, right? Allows you to build security into your application pipeline from the beginning versus having it as an afterthought. Ensuring that you enforce ongoing compliance from a consistent centralized place using a language everybody can speak, because that's going to give you the consistency. Everybody from Windows to Linux to networking to even security. You want everybody to speak the same language. This was another use case. This was at a government customer that I did a proof of concept for in Tennessee. They said, I cannot handle having the networking team write their scripts in one language. Have the Windows team writing their scripts in PowerShell, then I have the Linux team writing theirs in Bash. I need everyone to speak the same language and write the same language, because then when somebody leaves, okay, no big deal. I don't have to retrain them in this custom scripting language they decided to write their scripts, and you have that consistency. Everything is backed by GitHub. You have a change log. So you want to have it be able, with automation gives you the ability to create that security compliant host, gives you that repeatability, ability to share, verify, a continuous monitoring. And then if you want to successfully do system configuration management and DevSecOps and the CICD pipeline, et cetera, you have to have some sort of automation strategy in place. Automation is key to both of these. So how can Red Hat help? In case you have an idea in terms of, this is like, I guess, Princess Leia. If you want to make your cat look like Princess Leia, that's what that is. So we don't have security products at Red Hat in terms of we don't have a SKU that we sell you to say, we're not like Tenable Nessus or Qualys or things like that, where we sell you a security product. However, security is baked into all of our products. We think about it continuously throughout our portfolio, from helping you design security in from the start with things like innovation labs, our consulting services, the security guides that we produce. We give you the tools to build security into your application from our middleware portfolio, to OpenShift itself, to 3-scale for API, securing API endpoints, etc. We give you a secure platform, everything from Red Hat Enterprise Linux to all of the products that are layered and installed on top of Red Hat Enterprise Linux, from Red Hat Virtualization, Red Hat OpenShift, Red Hat OpenStack, Red Hat Storage. All of these products inherit the security benefits of our base operating system, Red Hat Enterprise Linux. We give you management tools to help you automate things like security and things like compliance. We give you the ability to adapt in terms of Red Hat security advisories, or our Red Hat Insights product, which is our SaaS offering, which is, you can argue, the closest that we have to a security product, in the sense that, okay, we're going to tell you what's wrong with your environment in terms of security issues, performance issues, security issues, performance issues, configuration issues, availability, those kinds of issues we tell you. But not only do we tell you, we actually give you fixes in terms of Ansible playbooks. And so, and that's all knowledge based on that we have, based on our Red Hat security team and also our products, our support tickets that are open. So this is the kind of AI, ML type of knowledge that we have, that we give you this customized info for your infrastructure. So we have security throughout the life cycle that maps to our products. We have security throughout our entire stack. Now, I want to start with OpenSCAP, which is our built. Many customers do not realize you have this for free. So what it is that this is our built-in security automation tool. And what it is it is our NIST validated and certified SCAP scanner by Red Hat. If you go to the SCAP website, there are other very expensive tools out there. Many customers actually are required to use them. Auditors will use them, like Qualys, Tenable Nessus, etc. But what you can do, and what I've seen our government customers do in the US, for example, is the Linux team will be proactive about scanning with OpenSCAP because it is free with Red Hat Enterprise Linux, and it is free with Satellite. It's in the base channel. So what I've seen is the Linux team will actually be proactive about doing these scans. What it does is it scans both systems and containers for two things. It scans it for known vulnerabilities, and it scans it for compliance to security baselines. If you go to openscap.org, yeah, it's great, you'll get the scanner, but what good is the scanner if you don't have content? Inside our RHEL engineering team, we actually have engineers who create this content. So there is a content for PCI DSS technical controls. There is content for US government baselines. There's content for Center for Internet Security, kind of like a twist on it called C2S. Things like that. So we give you this so that now you can use this to not only scan your system for vulnerabilities, but you can scan it to say, hey, I wonder if this my RHEL system is compliant to PCI DSS technical controls. Run the scan. You can do this, and not only do we give you the ability to scan, but we actually also give you Ansible playbooks. In RHEL 7.5, we actually give you already written and Red Hat supported Ansible playbooks for these security profiles that we ship. There's a playbook out there for the US Department of Defense STIG. There's a playbook out there for PCI DSS technical controls, all that stuff. It's in like a directory in your system, user share, etc. Again, it's included in the base channel. We ship that NIST validated content. We also ship this a tool called SCAP Workbench, which is also free with RHEL. What this is not only is a GUI front end for the scanner, but it is also our, what most customers use it for is to tailor content. What I mean is modify content. Maybe you say, oh, you know what, my company, I don't need to check this particular security check, or I don't need to, make sure that my passwords are changed every 30 days. I just want to uncheck things I don't want and check things I do want, and then SCAP Workbench will spit out the custom content, which now you can use in your scanning and your remediation. So, for example, in RHEL 7.5, I told you that we introduced the ability to do security remediations first. We give you there's 3 use cases. We give you the playbooks, which means that you can apply these pre-generated playbooks. Number 2 use cases, maybe I have a custom playbook, custom profile that I created with SCAP Workbench. give me a playbook for that. You can do that as well. Last use case is maybe I don't want a playbook with every single one of these security checks. I just want the playbook for the fixes. That's the third use case that you can use it for. So again, you can do all of this, right from your RHEL system. And because we give you the playbooks, you can actually use those playbooks to do these remediations at scale. Now, you can also, we also introduced this capability in RHEL 7.5, which is the ability to harden container images. So first, three use cases here also, which is you can scan the container for unpatched software. Next is actually scanning it for compliance to configuration baselines. Again, maybe I want to scan that and create a hardened image for that is already compliant to PCI DSS. Right? So I could do that as one of the first steps to create that hardened image for my containerized infrastructure. Then I can also have the ability to remediate that container as well. So these are the new features that we introduced in RHEL 7.5. Now, the report that OpenSCAP generates was designed to make auditors happy. Why? Because it's this red light, green light format. This is what passes, this is what doesn't pass, these are how many checks passed. Here is the exact rule we're checking. Here's a detailed description. Here is why you skipped it and the rationale why that rule might have been skipped. Print that report out and hand it to the auditor and you're done. So that's kind of like this easy button. Now, one of the things you want to note about OpenSCAP is it does local scanning of a single machine. Most customers, of course, want to do this at scale and also for a hybrid environment. Whether it's Windows, VMware, whatever, across their applications and across their infrastructure. So the key there is for the application, of course, the CICD pipeline that you build in OpenShift will give you that automated security and compliance those steps you can do by baking in security into all of those steps that you create in your CICD pipeline. We talked about OpenShift. Now, what about the operations? What about the infrastructure? Ansible. Ansible is our automation tool, automation language. It's very powerful because it is so easy to use. If you know XML, you know JSON, any of these, you can read YAML. This is something you can learn, in a very short amount of time. That it is also very strategic at Red Hat in the sense that it is included literally in all of our products, or if it's not, it's going to be. The other thing is that this is another reason why it's so easy to get started is we give you hundreds of modules and other hundreds of roles. So it's like you can already use created, you can, in addition to these, all these modules and roles, you can actually now create these playbooks in a much faster fashion, right? Red Hat Satellite is our managing RHEL at scale. I'm sure many of you are using that for content management, subscription management, patching, provisioning, configuration management. And I talked about Insights, which is our SaaS offering. Now, what we're going to see is, okay, now using that Red Hat technology, which we saw in the previous slide, how can I do the following? And this is where you're going to see an actual environment that I created with my lab teammates to do the security compliant host at provisioning time, do continuous monitoring and security for not only VMs, but also containers. And so in both an operations view and an applications view. Automate ongoing security and compliance remediation, enforce governance and compliance in an automated fashion. You want to have this limited visibility to restricted users, whether it is maybe a restricted admin, maybe it is the security team, maybe it is just a regular user. Proactive security and automated risk management. So provisioning a security compliant host. There's different ways to do it. Number one, if you have noticed the RHEL installer, you can do it in the RHEL installer. You can create a system just directly from the RHEL installer that is locked down to the security controls that we ship natively. You can, of course, do this in Anaconda. You can also use Satellite. Satellite 6 introduced the capability to do SCAP. It has a capability to do OpenSCAP scans and remediations directly from there as well. The other thing is in Satellite is in 6.4, we introduced the capability to input tailoring files. So again, I have a custom profile and I want to have it imported into Satellite and do my scanning from there. for RHEL systems at scale. I can do that. I'm going to show you the more interesting use cases, which is with Ansible. All the automation you're about to see is all written in Ansible. Not only that, I have all the Ansible playbooks that I'm going to share with you. It's all publicly available on GitHub. The lab environment you're about to see is also available to you for Red Hat partners. It's on Red Hat Partner Product Demo System. If you're not a Red Hat partner, you can actually work with your Red Hat account team. They can provision it, and then you can play around with this environment there. This was, like I said, we delivered it at Red Hat Summit last month. Okay, so provisioning a security compliant host. The decision was made that we are going, for that lab environment, that we are going to expose or show the automation via Cloud Forms. Do you have to use Cloud Forms? No. And do you have to do it like I show it? No. Remember, this is all about showing you the Red Hat buffet, and then you pick and choose what's relevant to you. Now, we've made the decision to display all automation, all orchestration of the automation to be shown through Cloud Forms. But all the actual work, all the scripts, all the code is all Ansible. So this is the first case. The user comes in, they're going to press order, and that's going to provision a lockdown RHEL machine. Now that lockdown RHEL machine, when they press order, this is what we have allowed the user to provision. Okay, they can name the VM, but they can't decide what the IP address is going to be for the VM. I, as admin, have decided that. I, as admin, also gave you a list of profiles that I would like you to lock this thing down to. Now, where it's getting this list of profiles is actually the Ansible playbook actually looks in the user shared directory that I talked about earlier, where those Ansible playbooks live. And we just expose it as a drop-down list of profiles that we want the user to lock the system down from. So when they press submit, what happens is CloudForms has Ansible inside, which means that all the automation that it launches can launch Ansible playbooks directly from CloudForms. So you can see here in the far right that it's actually launching an Ansible playbook. It's at the playbook's a Rev provisioning YAML playbook. So it's a playbook that's provisioning a RHEL machine inside Rev. And then what's happening is you can see all the Ansible steps that it's going through the steps in my playbook. And it's things like registering it to satellite or whatever else you want to put in that playbook. Now, one of the last things that you see in the playbook is this running the SCAP SCAP remediation playbooks. So what it's doing is it's actually going to that user shared directory, and it's actually, as part of the playbook, it's locking down that system by running the playbook, which is for that particular profile. So when you look inside, now that it's provisioned, one of the things CloudForms does is it actually gives you visibility into the environment. And I'm not just talking about things you know about from vCenter. It's things like what's the packages and what registry keys and values for Windows machines. So one of the things our government customers would use it for is they would say, okay, well, you know what's in these machines. You can also create custom control policies. So I'm going to say that unless I know what's exactly in this machine, I'm not going to allow it to run in production, and I'm not going to allow it to turn it on because you have this visibility into that environment. So when you look at that provisioned environment, you can see the IP address, you can see what package is installed, and all this other information. We'll see a little more detail about what's inside those. Now, enforcing compliance with security policies in an automated fashion, how can you do that? Now, I told you that you can create restricted users. So I created this restricted user just called lab user. This user cannot see any machines in their environment except theirs. In this case, they have the OpenStack environment, and that's it. There's other environments in there like Amazon and others, but they can't see it because they only own the OpenStack environment. So they're looking at this user's looking at their OpenStack instance, and they immediately see that it's not compliant. And because this control policy for Meltdown Inspector, specifically looking at the kernel fixes for Meltdown Inspector, and I'm not looking at the firmware fixes that are required, that control policy that was created was applied. And the control policy, all it does is looks to see what version of the kernel it is. You can actually create that right in the GUI. So here it's not compliant. I dig in to find out why, And it's because it's vulnerable to Meltdown Inspector. It kind of says, okay, this is vulnerable to Meltdown Inspector. So without me doing a single thing, I just went to the VM. The control policy looked at every single machine in the environment and told me in a proactive way that this is vulnerable to Meltdown Inspector. Now, if I find out why that's the case, I can dig into the packages. And then here's all the packages, release number and version number of all the packages installed in that environment. And you can see for under kernel that the older version of the kernel is installed, and therefore that's the reason why this control policy is failing. So now I've updated the kernel. I did that already behind the scenes. And then I rerun the scan. When I rerun the scan, and then I rerun the compliance check, and then that's going to come back compliant because of the fact that now it has the updated kernel. Now, I told you about another restricted user, which is the security user. And I have allowed the security user to do only two things. This user can see reports, and this user can create reports, see reports, and this user can also look inside specific systems without SSH access. So I'm going to create a report that says host, show me all the hosts. I don't care if it's living in VMware. I don't care if it's in Amazon. I don't care if it's in Azure. Show me every single host that is vulnerable to Meltdown Inspector, and show me which provider is it. Is it a Red Hat virtualization system? Is it a VMware system? Show me what is the name of that provider. And tell me if it's vulnerable to Meltdown Inspector from the kernel point of view. For VMs as well, give me a report of all the systems that are vulnerable of VMs that are vulnerable to Meltdown Inspector. Now, I've also given the security user the ability to look inside files. So here's a file. Here's a machine. I'm going to go into files. And here's all the configuration files. You can see, there's everything from etc hosts to etc sshd config and all those kinds of files. So I can actually look inside those files. I haven't SSH'd into it, right? This is just by clicking on the GUI. Now the security user can see exactly what's in this case, etc ssh sshd config. So without root access to the machine and without SSHing into the machine, now you've empowered the security team to get information they need without bothering the operations. This was, again, a use case that we did for the POs, for a proof of concept. The other thing that, let's say now back to the admin. So let's say this was another use case for one of my teammates in the US West commercial customer, and what they wanted to do is, when they have an OpenStack environment and they automatically wanted that OpenStack instance when it turns on to be put in a very specific security group when the machine powers on. So that's what this does. When I power that machine OpenStack instance on, it's going to attach it to the production security group. Okay, so now kind of let's look at the OpenShift side. So automated security and compliance with Red Hat OpenShift. Now, we had a government panel, first for OpenShift comments, and second, we had DevNation Federal, where various US government customers came to talk about their journey to DevOps and security with DevOps, and their journey in terms of what their challenges were, things like that. And what they say when you listen, these are links to actual the YouTube videos. They were both recorded. What they say is, hey, security, you have to have that consistency, that repeatability, and actually adopting a security container platform will improve your security. And so this is a mix of both the leads of development, operations, and security talking about their journey. Now, what they say is, okay, now we've noticed that there is that not only higher developer productivity, but more security is built in. You have that faster, easier deployment for operations. You don't have this back and forth, and you don't have this constant blaming. You have a way that you can do consistently things like secrets management, record of changes, a consistent way to do patching, things like that. The other things that they mentioned is now you have a standard hardened infrastructure. You effectively created application whitelisting by doing read-only containers. You're consistently redeploying from a known good source. You have that standardized base container images, right? You're not patching, and it's not like a VM, right? You're constantly, changing the system. You're always redeploying when from a known good source. Because they decided, look, we don't need SSH. I have the CICD pipeline that I developed. Why do I need to have SSH? So they turned off SSH completely. So now you don't even have humans in production. Patching improvements, you have that minimal OS, and now security team is not the last to know. They're actually building the CICD pipeline with the operations and with the development teams. Now, this is actually from the 2017 State of Software Supply Chain paper by Sonatype, and what they say is 84% of open source projects do not fix known security defects. And I'm sure, the previous speaker, you guys talked about how in Docker Hub, a lot of those have known security vulnerabilities. So this is a known thing. Now, you want to start with quality parts. In terms of Red Hat, we have the container catalog, Red Hat container catalog, where this is our secure registry. This, we sign these images. We make sure that it goes through our own secure supply chain. What do I mean by that? Well, we are leaders in the community. We're very picky about what packages we pick. We do both manual and automated inspection of our code. We have very specific packaging guidelines. We always build from source. We do extensive quality engineering and quality assurance testing on all of the software that we ship. We have security certifications for our products. For example, in Red Hat Enterprise Linux, all versions are certified with, they are both Common Criteria certified and FIPS 140-2 certified. We also do signing, as I said, secure distribution of our packages. Of course, we provide enterprise support, and then we have the backing of Red Hat product security to provide those patches for our products. So you never want to pass the defects to downstream to work centers. This is a quote from the Phoenix project from the book. You want to make sure that you automate things like quality. You want to have the idea is that this CI/CD pipeline that you create inside OpenShift using the built-in Jenkins pipeline, for example, effectively gives you this secure software supply chain security, where you bake in security in each of these steps. And so now you have this software factory, almost like an assembly line, like a car assembly line, right? You have all of these steps where you have security gates in place for, looking at the code that got checked in, doing the unit tests, doing things like the static code analysis with tools like SonarQube, doing actually the scanning of the system itself, of the containers itself, these kinds of things, and then. When we look at the step of the scanning, for example, if you were to use Atomic Scan, if you were to use OpenSCAP, for example, you don't have to, but if you were, there is a security policy in place there that's baked in that says, hey, if you do the scan and you find a high severity vulnerability, what it does is that actually forces that container to never run in your environment again. So when this gets applied to your entire OpenShift environment, then when it sees a high severity vulnerability like you see here, when you try to launch that container, it prevents you from doing that. Now, as you guys know, we did acquire CoreOS, so this aspect in terms of OpenShift management, using CloudFormers specifically, that has a potential to evolve that, how we do that in terms of, maybe we'll introduce a way to do it using the CoreOS technology. This is still kind of in discussion in engineering and product management, but we're looking at options like that as well. So then, of course, since we know which containers are passing OpenSCAP scans and not, you can, of course, create a report as well. So what if you deployed it and then you find out, a new vulnerability comes out, et cetera? So again, you want to so that may get trickled through to your pipeline, right? So what if now you have 3 days to patch? So what you do is you want to patch, and then once you patch, like I said, you don't want to rebuild, and you don't want to rebuild and redeploy. You don't want to and then move it through the pipeline. So that's kind of the idea here. So this is DevSecOps. So when you have DevSecOps, you have everything as code. You automate everything. You have that CICD pipeline. You have rebuild versus repair. And then things like application and monitoring. And then that application is always releasable. The other thing I wanted to mention is that we have this idea of the security inheritance model, in the sense that you have security controls at the base, maybe that they're enterprise level security controls that are passwords or whatever it is, infrastructure that OpenShift runs on, and then the OpenShift platform itself. So the whole idea here is that when you have applications running on top of OpenShift, because of this inheritance model, you're inheriting the security controls of the enterprise security controls, the infrastructure and platform, so that now you can actually only worry about the security controls for your application, for example, because of this inheritance model that is in place. And this is actually what many of our US government customers follow, the idea that they have to pass something called, they have to have authority to operate, to make sure that in order to get these OpenShift, for example, in production, or the application on OpenShift in production. And so this is how they go about it with all the different security controls they have. They use this kind of layering method. So OpenShift brings all of this together. We give you the easy button in terms of enterprise Kubernetes, and also things like self-service, a service catalog. I'm sure you've heard more detail about this in some of the previous sessions. We also bake security in, everything from giving you the ability to create a secure CI/CD pipeline, giving you that secure container registry, giving you security, so that's control in terms of allowing you to bake security into your application and your application pipeline, building security into your infrastructure, into the actual OpenShift platform itself, giving you technology tools like network isolation or audit, or other technologies inside OpenShift that you can take advantage of as well. And of course, you can utilize our extended partner ecosystem to extend features that may be relevant to you, whether it's network security, or maybe you want to use an external vault from HashiCorp, things like that. So now kind of moving back to on the infrastructure side, let's say I want to do on a per VM basis scanning. So I want to, on a per VM basis, I want to scan that system. So and I want to do a drop down of the various profiles that we saw earlier, right? So I can do that. Maybe I want to as there's configuration changes or whatever, I want to be able to scan it once in a while, right, through the life cycle of that machine. So when I press scan, again, the automation is kicking off an Ansible playbook, which is going to do the scan. But as part of the Ansible playbook, it actually tags as well. So here, it's actually tagging it as it's not compliant to this custom profile that I created with SCAP Workbench, which just checks to see that certain packages are installed. And so now that I have everything tagged as compliant or non-compliant, I can have the security team run their own reports, right? Okay, show me every single system that is compliant or non-compliant to this custom profile. Show me every system that's compliant or non-compliant to the PCI DSS profile across my hybrid environment. I can also remediate. So when I press scan and remediate, these are actually launching, again, Ansible playbooks that is talking to satellite and using the OpenSCAP tool that's in satellite and talking via REST API. So when I press remediate, it's going to actually install those packages, which is the Ansible playbook is going to install those packages. So I'm just waiting to make sure that the aid package, for example, gets installed, and you can see that it gets installed at the push of that button. So when I redo the scan, you can see that now, okay, now the report comes back as compliant, whereas before it didn't. So now the last thing I want to talk about is Red Hat Insights. Now I said that Red Hat Insights is a tool that is a SaaS offering that tells you performance issues, security issues, configuration issues, and availability. So things like I'm going to go into this system, and then I'm going to see various different issues. I'm going to focus on security issues. So in this case, you can see the payload injection issue, and you can see there's an A next to it. So that A tells you that you can actually create an Ansible playbook for that particular issue. Or you can, that's where I put a check mark to say, I'm going to create a playbook for this particular issue. And I'm going to decide, well, do I want to press reboot? I mean, do I want to have force reboot, or do I want to have a reboot required, or do I not want to have that? So I can kind of make that decision as I create this planner. And then from there, I can actually download the playbook. It automatically generates that Ansible playbook for me. And then I can go into something like Tower, and then I can see those issues again from Tower, those security issues. And then I can, of course, once I have that playbook created, I can actually go ahead and then run that playbook. And then I can decide, okay, well, I want to have a playbook for all of the issues that Insights found. And then I can create the playbook and then again launch that playbook. Now, if you were at Red Hat Summit, they went a step further, which was they actually had a fix-it button where you don't have to download the playbook and run it. So we're working on automating all of this even further. And the next release of Insights will have these literally fix-it buttons, which is they're targeting roughly around late summer, early September timeframe. So again, you can use Red Hat technologies to do all of the things you just saw here, flexibility and choice. You pick what you want from the Red Hat buffet. Bring your buffet pants and pick what you want to eat, kind of thing. And what's relevant. This is all about baby steps. It's about what can I do to make me better than what I was yesterday, right? In terms of both infrastructure, in terms of both operations. The limits. This is one way of how you can do automation. This is not the only way. This is not the only automation strategy you can have in place. I told you that all of this demo is available hands-on. The lab doc is also on GitHub with detailed references in terms of well, how do I get an intro to OpenSCAP, or how does OpenSCAP work inside Satellite versus if I wanted to integrate it with Ansible, these kinds of things. So you can look at the lab docs there. If you go up one directory to just security demos, you'll actually see our second lab, which is RHEL Security Technologies. It goes through all the key RHEL security technologies, and we delivered that at Red Hat Summit this year as well. All the Ansible playbooks you saw are in that link, the second link. And then, of course, I utilized the RHEL 7.5 provided Ansible playbooks as well. And these slides are going to be available to you, too. Many Red Hat security demos were recorded, and including this version of this talk where I was mainly focused on operations. That was recorded, so it was our Red Hat security roadmap for hybrid cloud and also for the infrastructure and many, many others as well. And like I said, you can access that lab environment remotely, even though it's post-summit. All of that environment is accessible as well. So I want to thank you for your time. And I'll be at the networking thingy, so you can find me or get my card and email me later. I'll be happy to answer all your questions. Thank you very much.
Yeah, thank you.
Okay. All right, thank you.
Well,